Okay, Assalamualaikum. Very good morning. So, I already record the session. Today, we're going to continue our session. So, today, hopefully, we can finish the first part of how to at least to run the drill physics. Okay, and then after that, we can do next week. We can slowly do all the example because I know by doing example, then we can get a lot of idea from the example instead of just do the theory. So at least by next week kita boleh do sharing. You do the one example and then we can do sharing. So that I'm not going to be the one yang do all the talks here. Okay, so I share my screen right now. Okay, so to recap, a few minutes of recap. Boleh nampak ke? Can someone confirm it for me?
Nampak doktor.
Okay, nampak. Okay, saya before that saya kena tutup WhatsApp ni. Sekejap. Okay. Okay, so today to continue our session last week. Okay, software semua dah download DualSPHysics version 5. For your information, the version 5 is still beta version. Maksudnya dia punya GPU file still not available. I think they will be ready by April, May macam tu lah. So the only executable file yang ready adalah CPU. Tapi don't worry, by the time dia keluar nanti, at least we already do a lot of the example first using the CPU pun no problem because I think we're not going to run a very heavy case. Okay, we can use the version 5. But for those yang nak try to use GPU, we can try version 4. Nothing changed that much for the examples. Okay, just that if you want to do a complicated case, then barulah version 5 ada changes. Changes dia bagi tahu dalam this text. Right. Okay. So last week kita go for the example. Example under the main. Okay, so under the main ni, beza dia ada banyak example kat sini. But the main ni the one that the pioneer lah, the first different example, ada 17 example here that use the basic dual physics. Okay, basic punya dual physics punya foundation lah, fundamental. The rest tu is more on the extension of dual physics. Dia ada chrono project, mooring project, but the fundamental is the main folder, under the main folder. Okay, and then last week kita go for the dam break. Okay, dalam dam break ni there's a two cases, 3D and 2D. Okay, if you look at the output, this is the 3D and this is the 2D. Okay, 2D example. Okay, so dalam ni ada banyak, there's a lot of file, but don't worry, the SH file maybe not doesn't relate to you if you use Windows. So yang ni sebenarnya tak ada, jangan kisah. And then you ada GPU, you using GPU, CPU is for the 2D, and then 3D, CPU and GPU. So ini semua ni running punya file. The one yang jadi the input file is the definition file. So if you click on the DualSPHysics wiki, Okay, this one is okay. Assignment guide for dual physics. Dia dah bagi dalam dokumen inside the folder, but I think this one is much more easier to understand. If you look at if you click on the link that I've given in the chat, you see here the summarized thing, and make it easier for you to understand. Prerequisites before you run. Okay, so dekat sini, to run dual physics on a GPU using executable, only a NVIDIA CUDA enabled GPU card is needed, and the latest version of GPU driver must be installed. So ada case one of my student kata pakai laptop with AMD kan, so that one dia tak boleh nak run. So make sure you punya GPU is the NVIDIA CUDA enable GPU card. Ni kalau nak pakai GPU lah, kalau CPU GPU lah. So make sure check your laptop kalau dia GPU card dia ni NVIDIA ke ataupun AMD. Dan dia bagi sini overview dia. Ni macam kita tengok lah. Jangan risau. Okay. Dekat B dia bagi tahu contain the binary executable for Linux and Windows. Ini okey tak apa. Kita skip. Okay, so dia bagi tahu example. The main example will use the dual physics executable file. Example in Chrono, ini extension of project Chrono. Ni tak apa. Ni all these things you don't have to tengok. The only important is the main example. So dalam examples, in the main, you got the dam brake, period, moving square, external, sloshing tank. Okay, and then today we're going to do the dam brake 01 dam brake. Okay. Okay, tak apa, ni output binary file, semua ada output DPK. Okay, so to recap, last two weeks, overview of dual physics workflow. Okay, we have the pre-processing, number one, and after the pre-processing, the processing by dual physics, and after we have the output in binary format, then we do the post-processing. So the post-processing depends on your interest. If you only want to look at the fluid part, you only extract the fluid boundary, or you want to do the representation of isosurface, or you want to measure something. As a new one, the flow tools. Okay, so ini clear. So today kita akan buat pre-process. Kita tengok macam mana nak running the dash part. Okay. Okay, so now we're going to go back here. How to, before kita go to the pre-processing dia, okay, anything yang ada definition dot, dia punya input file dia is this DEF file. Okay, it can be any names, but if you find inside the dam brake, look for the DEF file, definition file. Kalau dalam ni ada one here, another one here. So this for 3D punya input, and this for 2D. Case dam brake validation 2D underscore DEF dot XML. Okay, so dia generate case akan take the input from this definition and akan generate input for dual physics. Okay. Setakat tu okay. Okay. If you want me to slow down, just unmute yourself. Okay, so kita go the way that we run the program is to use this command prompt ni. So they put every folder ada command prompt. You can use this one, or you can use the batch file. For example, I open the batch file, BAT is batch file, case break validation 2D underscore Windows 64 underscore CPU dot batch. Open. Sorry, open with, yeah, they can run nanti. Edit with notepad lah. Saya edit. Okay. So ini adalah bentuk dalam batch file. Tapi jangan pening, kita akan go one by one. Go one by one. Okay. Okay, so batch file ni, the reason we use batch file because kita tak perlu, we don't have to write everything one by one. We tekan batch file and the file will run terus from the generate case from here, from generating from the pre-processing, and then the terus process, and then the terus post-processing. All you need to do is set everything dalam batch file. Okay, so kalau tengok first on generate case. Okay. Kita tengok sini tulis set name sama dengan case break validation 2D. Maksudnya the name here equal to this name. So once the set directory out, the output directory out, name out. So the name here is case break lah, automatic. And then baru dia akan cari the executable file from the current folder. Okay, this is the current folder. Okay, current folder dia 01 break. First kali you kena cari the executable file because this is only all the input files. So they go 1, 2, 3 dot dot means you go out of the folder lah, 1, 2, 3, and then they masuk dalam inside the bin folder, and then sini and then into the Windows. Okay, this is all the executable file. Executable file is the acuan that already been compiled for you. So for those yang wanted to change the code, then you go to do the C++ programming, you compile and you replace you punya executable file here. But this one is the standard executable file without any changes. No, kalau you want to introduce something, you tak boleh change kat sini. You better go change at the code, the original code, the source, and then you compile, then they can jadi this executable file. So dia bagi tahu, okay, generate case, dia ambil gen case win64. So ada dua sini, gen case mk word, gen case Windows 64. So apa beza dia? Dia kata kat sini Jenkins MK 64. Okay, kat sini. Allow the user to create 65,000 floating. Tapi Jenkins Windows 64 only allow to create 240 objects. So kalau you guys tak guna that much object, better just Jenkins Windows 64 because it's faster and only need 50% less memory, large number of particles. Okay. So going back to the folder, so the first in the first part in the batch file ni dia panggil all the executable yang dia nak guna. For preprocessing, he call generate case. For processing, dia panggil either CPU or GPU. This DualSPHysics CPU. Tapi GPU tak ada lagi pun. Yeah. Okay, it's okay. And then for post-processing, dia panggil boundary VTK, dia panggil part VTK, dia panggil part VTK out, measure to compute force, dia panggil everything, ISO surface, flow tool, floating info. You can panggil everything, it's okay because if you don't use it, the next one, the run and post-processing bawah ni yang akan you can decide to use. It's okay to call everything, and then if you decide you don't want to use it, it's fine. In the next part of the batch file, you don't have to write anything pun okay. Tapi if you kata I don't want to use post-processing, only you want to run the DualSPHysics, you want to do the post-processing later. I mean, you want to run dulu 10 cases, and then after that, you want to go on the post-processing, one by one, post-processing. Post-processing. So you can stop at DualSPHysics. Sini je, you call and then you run everything. You run 10 cases, 100 cases, and after that, baru you buat post-processing, one by one. So, you jimat masa and you be in computational cost because you don't have to run everything. Okay, and then after the call, you can go back to your case lah. So kat sini menu dia kata kalau if ada folder exists already, dia akan delete the folder. Dia akan gantikan dengan new folder. If you don't want that, you want it to continue untuk add into the same folder, you can just delete this command. Okay. And then next, after you dah call the executable file, then you can run. Okay, ini tak apa, yang ni dia nak katakan kalau result is remove, kalau ada exist, you remove all the result dalam folder tu. Ini very penting ni. Number 3, execute Jenkins to create initial file for simulation. So dekat sini Jenkins name underscore def. So name ni name apa? So name ni dia ambil atas balik, then this name is template. So be careful lah kalau if you want to copy other template, make sure the name bertukar lah. If you change the name into test 1, test 2, so you have to make sure the name here also change. Then direction out, save all. Okay, so apa maksud save all ni? You boleh tengok dekat dalam wiki dia, under ni 5.4.1 to run Jenkins. Kita sini save, you can put save, lepas tu dot tu, double dot tu, plus ataupun minus. Kalau you put all to choose all. Kalau you kat depan dia minus, so dia you reject all, you tak simpan semua. Or you kata nak simpan binary format saja. And then you boleh letak kat sini save bi ataupun btk all ataupun btk boundary. Tapi better all lah. And then after dia run ni, barulah dia keluar all this file ni. All this case all, case boundary, case float, case actual, TP to be the input to the DualSPHysics. And then execute DualSPHysics to simulate SPH method. So all this file will be the input to DualSPHysics. So DualSPHysics name minus sb atau minus dash sbres. So aku maksud sbres tu boleh tengok dekat sini processing dia sini 5.5 processing. Okay. Sekejap. DualSPHysics, okay. DualSPHysics. Ni tu run DualSPHysics. Okay. Dekat 5.5.1 to run DualSPHysics. Okay. So to run DualSPHysics, sini je boleh. DualSPHysics directory out name dash sbres dash cpu untuk enable on the CPU ataupun GPU. Tapi saya tak perlu pun. Once dia dah run sini, sebab kalau you yes, ini tulis CPU, so you don't need to tak CPU. Because sini you put CPU here equal to this CPU batch. So kalau you want to change, you just can change GPU here. Okay. And the good thing about the DualSPHysics is that you can continue. You don't have to rerun. Contohnya, you run from time 1 series until 69. Then you stop because you nak balik rumah or you want to take a break. Then you don't have to rerun. You can restart at 90 because they save all the files into part. Kan? Ini adalah part ni. The part. And every part tu in time series. Part. Kalau ada 10 second, t equal to 1 second, part 1. So they put every interaction in one file. Itu this binary file. So you have part 1 until part 10, equivalent to 1 to 10 seconds. You don't have to rerun. You can start at 11 to 20. Kalau you nak sambung 20 second, and then you nak sambung lagi 20 to 30. Kalau you nak run for 1 hour punya case, you can do bit by bit, speed. You run half and then you check the result. You say, okay, I need more result. So you just continue je. You don't have to rerun unless you change the parameter lah. Okay, so yang ni tak apa. Yang the complicated, you don't have to tengok. It will be default. By option, it will be default. Okay. Then, okay dah setakat tu? Ada soalan? Saya tak nampak. Okay, before kita go for the post-processing. Type 1 if you want me to proceed, or you want. Okay. Then after that, you can stop here. Okay. On the run, you don't have to go to the post-processing because you already have all this info. You can stop there, or you can next you can go for the post-processing lah. So post-processing ni ada banyak, ada 4. Tengok atas lagi. I think 1. So post-processing ada part VTK where you can extract the fluid part, the boundary part, the moving part, the floating part, or you just want to focus on the boundary saja. So you want to focus on the structure, the moving structure, floating structure. Ni kalau ada case structure sajalah, fix. Then as a surface, measure tu ada another one, flow tools. The new one, the flow tools. So in this case, dia call part VTK. Maksud dia one part VTK. And then dia call ISO surface. This one. Part VTK out ni tak apalah, dia just want to tengok partikel mana yang keluar out. You don't have to sebenarnya. Ini particle out ni, if you want to do like coastal defense and ada air keluar, you want to check how much particles yang excluded from your simulation. Okay, part VTK here. Okay, so tengok part VTK. First part VTK. Part VTK kat sini. Okay, kat sini lah you boleh pilih. You nak save dalam bentuk apa first. The output file can be saved in VTK file. VTK file ni for you to run, nak tengok visualize in ParaView. You nak terus masukkan dalam Excel file boleh, or dalam this format ESCI ni. Okay, so in this way you can simulate guna ParaView, GNU plot, Octave, MATLAB, everything. So dalam case dam break ni, he or she use save VTK because dia maybe nak visualize dalam ParaView. Okay, and then this file can be generated either by MK. Kita ada define MK. Kalau if you ada banyak fluid dalam tu atau banyak object, you can define by MK or ID particle tu, type of particle, position of particle pun boleh, or by velocity. So you kata velocity of particle yang lebih pada ni saja dia nak extract. So we can choose to include ataupun not include the particle dengan menggunakan plus all or minus all. You nak include boundaries boleh, tak nak boundary boleh, floating bodies boleh, fluid particle boleh. So tengok kat sini. For the part VTK, dia nak part fluid. Okay. part fluid, which is part fluid. Part fluid only type. Okay, only type. So by the type of the particle, only type. Minus all. Minus all maksud dia buang semua kecuali fluid saja. Minus all, only type, dia want only fluid type saja. Dia buang semua. And then minus a dash at bars. Maksudnya different particle data, physical quantity, monitor variation bar ni, the physical quantity apa yang dia nak. Dia buang semua dulu di minus bar sini. Dia plus ID, dia nak ID ID of particle, dia nak velocity of the fluid particle, they want rho of the fluid particle, they want pressure of the fluid particle, and VOR, vorticity of the fluid particle. So they go one by one. The first, from the part BTK, they want part fluid. They want only fluid type. From the fluid type, they want IDP, velocity, rho, pressure. So you can mix and match. If you don't want ID, you want the only velocity, you can put velocity. If you want mass, you can include mass or volume. And then from the part VTK as well, you want the boundary part. So only type minus all, they remove everything, only want the boundary. And then for the variance, I'm not sure if VAR equal to what. They want all the physical quantity. They minus all the physical quantity. Dia tak nak buat. And then dash last to 0. Okay, this one. Okay, this last one I have to check. I'm not sure what is. This last. If you don't understand, you can always check the boundary lah. Boundary. Okay. Kalau dia fill, you will go to fill. So this is how you extract the part fluid dengan juga part boundary. And then the next one, dia ambil part VTK out. Okay, part VTK out. Okay, part VTK. Save VTK, save in VTK file. Save the name of the folder as part fluid out. Save, resume. So kat sini tulis sini, information with excluded particles can be stored in CSV file and VTK can be generated with those particles. So boleh pilih CSV or VTK. So dia resume fluid out. And then last, dia nak execute ISO surface to create VTK file with slice of surface. Okay, because ISO surface ni you can create slices. Kalau you ada 3D, you boleh slice dia, and then you boleh tengok the vorticity or velocity of that slice. Itu penting juga slice ni, you nak slice into the interior. So tengok dekat ISO surface. Okay, ISO surface dekat info. Yes, 5.6.6 surface representation, ISO surface. Okay. So ISO surface ni is a visualization technique to represent the surface instead of particles. So you can see here is the particles. ISO surface can make it look more realistic. Okay. So tengok sini, the output binary adalah save to VTK adalah dash save ISO. Tapi dia tengok sini ditulis ni dash save slice. Dia nak save slice. So tengok kat mana tulis save slice. So save slice dekat sini. In addition, a useful option is to save a VTK file with the slice of ISO surface. The user can indicate how the vertices are processed to create the slice. The plane of the slice can also be defined using a point and vector. Kalau you rasa macam susah, you save ISO pun, dia boleh save semua. And then you can slice later, the review pun can be done. This slide. Measure tool dalamnya. Okay, nanti in other case you can find out dalam different example dia ada, kalau dia nak extract the floating motion saja. If you have something yang float ni different sikit dengan a fixed structure. So kalau you want to look at the structure macam ship ke floating apa lagi? Floating platform. Okay. So you can extract out using the floating punya info. Okay. Because floating ni dia ada pergerakan dari segi search, pitch dia naik macam tu, dia pusing macam tu, dia ada rotating, dia ada heave, dia ada pitch. So it's very complicated sikit punya pergerakan. Okay, and then dia ada compute force. Selain daripada part VTK, ISO surface, compute force ni you can detect forces dekat area tu. Macam kita nak buat impact of wave to the coastal defense, so compute force is suitable for that. And kita boleh save dalam VTK, CSV, and ACCI lah. Okay, and then kita boleh tengok moment dia dekat mana, kita boleh pinpoint tempat tu. Example dalam main sloshing tank ada, nanti kita akan tengok one by one. And then measure tool, yang last, measure tool ni di mana kita boleh extract at any point dalam our simulation tu the pressure, velocity, the surface elevation. Okay, this one dalam dam break tu ada, kita beritahu 01 dam break pressure props. Ini .pdf. So dia beritahu if you want to put the measure tools tu, jangan letak betul-betul direct on the structure, letak depan sikit, the point pressure dia around 1.5 distance, because dia takut nanti kalau dekat sangat dia punya interpolation tu become too small, so the pressure yang tunjuk tu is not correct. So they put here depan ni the prop pressure. So this one can be also implement in coastal defense. You want to put point pressure here. So when the wave impact or hit the structure, so you can extract the pressure here. Either extract pressure boleh, velocity boleh, you can terus compute force. Force you can compute dekat atas structure tu. Pressure mungkin nak tengok pressure dekat juga, of course lah, on the structure, maybe the one that impact dekat sini, you can put the prop there, and then you can compare with the one yang you do in situ ataupun dalam numerical plan. Okay. So kalau for those yang and then you dah set, baru dah you boleh try. For example, I try to click on we already template validation 2D. I click on the batch file here. I click on CPU because I think the version 5 don't have the GPU yet. When I click it, okay, because I run dalam OneDrive, so dia a bit masa sikit. Okay, this is what happened when you keep in OneDrive or Dropbox. So it's better to just keep in different drive. Okay. So you can see when you run, dia akan ada a summary of what you have choose. Okay. Sorry, summary dia. Tapi nanti dia akan keluar summary dia. How many particle you have? Particle summary ada, total particle 21,000, and then part 1, part 2, part 3, semua dia akan save inside one file, part 1. So kalau you delete part 12, part 13 pun, you can still visualize the part 1 until part 13. So that's the good part. Dia tak ada dalam, for example, XBish ke apa ke, dia akan compile in one output file. So if you delete one output file tu, you lost it. But here, if you delete part 19, part 18, you can still visualize part 1 until part 16. And you can still continue back from part 16 onwards. So beritahu the times needed, the total time, total step, and finish time when. So you can compare your finish time. CPU versus GPU. So CPU biasalah lambat sikit. So if you tekan delete here, okay, dia tak akan proses. Dia akan follow your batch file lah. Meaning that they have run dulu the DualSPHysics. Now is running the DualSPHysics punya running. Once they finish running the DualSPHysics, every part dah keluar, and then baru they proceed to post processing. So they akan create the part fluid, BTK, part bang BTK, part out BTK. So once dah keluar all these parts, you can read the VTK file dalam I can run the GPU one. I have the version 4.4 as well. There. Oh, I think I already have. Okay, so any question for the first example? Okay, while waiting, okay, I think the best next example to do, okay, I think the best thing is go through number 5. Number 5, running DualSPHysics inside the wiki. It test case. Dia because of the OneDrive main example. Okay, I think the best example, you can skip number 2, 3, 4, 5. Not this one. This the wave part. The wave part may be relevant to you. So we have number 6, wave maker. Number 7, wave maker file. Number 8, wave flat. Number 9, wave piston. Number 10, with awas. This is it the absorb the wave. Yes. Okay, so we look at number 6 while waiting for my case to run. Okay, this one is faster. You see, GPU only 2 minutes to run the same case. We finish 10:48. Okay, number 6. Okay. Okay, so I think number 6 is good to do. So next week, I'm hoping for you guys to do number 6, and then we can discuss on what have you learned from number 6. And then for those yang finish number 6, you can try to number 7. Not just do, try how they implement different post-processing. For this part, we implement surface. Want to track the surface elevation. So this is very important because when you're running program, then fluid is things that important input is the surface elevation here. When you using mind of your focus, doesn't mean that it can sustain the wave height to some similar with the wave maker, that when it creates a wave using a wave maker ataupun from swan or from mic dapat input to create the wave, you have to make sure that sampai dekat when the wave to reach the near shore, it can sustain a significant wave height. Dia tak lost ataupun die in the middle. So there's the objective of this number 6. Number 6. Okay, so number 7, wave. Okay, is very interesting because they validate with experiment data. So I think this one you should try. So they have wave maker. Here they run. So it's similar with a numerical 10 dekat CIM2 experiment. You do the wave surface elevation and the force exerted onto the wall. For example, you have defenses here or damping punya structure. So you track the elevation point here. Nak tengok surface elevation because you want to know how high the wave is. For example, nanti you buat on the coastal defense, you want to know the storm surge punya height. Okay, you know the overall height, from the offshore, you tengok from the buoy and then you buat using mic. But when it comes closer to nearshore, how can you really know the height? So this case can track the wave height closer to the structure. They take the bathymetry as well, they can the surface elevation. Okay, and except bagi eksperimen case with the experimental value, the same point yang track WG1, WG2, WG3. This is WG1, WG2, WG3. Ada kat sini. Okay, and then structure dia STL. Okay, this one kita akan learn lepas ni. Doesn't have to, you don't have to draw yourself. If I nak draw yourself, you will do in FreeCAD and then you convert into STL. You can read through the structure. So you see, dalam case FrameMaker ni, they track each point, WG1, WG3, WG1, WG2, WG3. They track point and then dia nak buat comparison dengan experiment value. So if you have time, you can try either betul tak value dia, because dia akan extract keluar dalam CSV file. So you can plot. Dia tengok sama tu. So for next week, number 6, number 7, now still what the simple structure, so we just use as it is. If you have complex structure, then we will for the design physics. Okay, now dia dah habis. Press any key to continue. You just press any key. Okay, so the finish. Then break. So then break. Dalam BTK file, tapi sini because there is a reason why berat. Everything it is not just BTK file. They save the binary file as well. And then particles. This all the part fluid. The BTK, one file is already 1000 KB. If you have 3D file, one file to cost you lot cost. Part fluid baru and then part fluid. So whenever I don't need this part, the post-processing punya data, I just need the binary file. I will delete this particle and surface. I always generate. You can always pick to generate at what point as well. You want to 12 only for post-processing pun you can. So this one slice, and then you can open para view. Komputer saya pun dah siap. Right, okay. For the last part, you can open Paraview. So this Paraview can download. So I will teach this one later. You can open the file that you just have finished running. Or the depth, the physics for sample mean, then break out. The 4 or 5 that version open version check again. Sample 4.4. Okay. Where's my can break reality out. Okay. Then break. Yeah. Sorry, something happened. I'm not sure why it doesn't fix the jam break. This jam break. Does it appear in my old files? There are 4 show examples. Here are to show example particle part fruit. Show part only. Okay, so okay. So class. So lebih kurang macam tu. Okay, part fruit. Okay, ni put row block T. So you can see the growth of the wave maker. Saya tahu kenapa tak keluar, mungkin lambat sikit kot. Because the reason is try to not save it in OneDrive. Kenapa dia nak OneDrive? Yeah. Oh, okay, understood. Okay. So I save it in OneDrive. So OneDrive jangan run dalam, put it in another folder. So Ni adalah slice. This is for slice. Then break. And for those one, I'm not sure to show only a slice of it. Then you can use. Okay. Any question on that? Saya terang dalam run drive, OneDrive. All the data is going to be very heavy. Any questions? So I'm hoping that you can try number 6 and 7 next week. Kurang dalam apa ni? Okay, yang if not error level tu kita masukkan apa ya? Ke tak payah usik yang tu. Jangan usik. Maksudnya if anything happen, dia akan keluar error. So jangan usik yang tu. We just change the maksudnya if something happen, dia error and then dia akan go to fail. Meaning that something that you in your description tu is wrong. You need to revise lah. Jangan usik yang tu. Dan juga yang execution velocity pressure benda tu akan calculate sendiri ya. Dia akan calculate, dia akan interpolate. Kita just need to give the point saja. Yang tu kita akan tengok next week. Dia guna measure tool where you need to pinpoint where do you want to extract the velocity pressure. Dia takkan ada exact tapi dia akan interpolate that area. Pada view software explanation, ni nama yang depan kita buat. Try number, okay, now you do number, example number 6 and 7. Try buat dekat rumah. Next week, kita buat sharing. You guys kena share balik apa yang you guys faham from 6 and 7 tu. Boleh ke? Okay. So ada persoalan lagi setakat tu. I think itu dah is enough. Next week, I just listen to you guys lah. Number 2 and number 6 and number 7 wave maker and wave maker 5. Are you okay guys? Boleh. Okay. So kalau tak ada apa, is already 1 hour. Okay, they're not going to drag it too long. Nothing? Okay, cuba. Boleh? Okay, cuba dulu. Bakat sekarang tak buka semester lagi, so it's a good opportunity for you to try. And because this platform is still new, you continue to do it, insyaAllah. I think very few people only use DualSPHysics in Malaysia. Similar to exhibition juga tu, macam to try to learn something yang orang tak guna. So nanti one day you can become the expert. Okay, I stop sharing. Okay, I think that's all for today. Can't wait to see you guys next week. Okay, thank you so much. Assalamualaikum warahmatullahi wabarakatuh.